This is our video for EA 13 and 14. This example says, sketch a graph that shows a relationship between two variables, two examples on the same axes. Label each trend line with the slope value. So we're going to use our drop height in centimeters and our bounce height in centimeters. We're going to use this example from our class to compare, sorry, this is also in centimeters, to compare two different balls. So we can imagine we could have like a super ball, like a super, I'm going to actually make this the super bouncy ball with a slope of 0.75 centimeters per centimeter. These units, by the way, are really kind of weird. We talked about this in a lot of the classes. Don't worry too much about that. It'll be much more common to see slope units that look like this, like points per hour with two different units. And another ball that we could imagine is, say, an old tennis ball. We used a kind of a newer tennis ball in class, but you can imagine that an old tennis ball would be even less bouncy. The slope could be 0.25 centimeters per centimeter. So you can see there's a difference in the slopes for sure. We want to think about what that difference in the slope means. We talked about this in class. We want to summarize this as follows. Oops, I got a pencil in here. The slope shows how bouncy the ball is. For example, a basketball with less air inside, so you can imagine like a flat basketball, would be less bouncy, a smaller slope. So in this one number, this bounciness of the ball, we can describe this quality of the ball. It's not how high it bounces, because that depends on the drop height. It is like how bouncy it is, like as a ball. No matter how high you drop it from, that quality of the ball doesn't change. But we can change it by, for example, making the thing out of a different material, or taking air out of the basketball to make it more flat, or whatever. The slope statement is another way to describe the slope of the ball, or the slope of any relationship, very easily. In general, we want to follow this form. So we're going to actually make some notes here that say, use this form when you make a slope statement. For each additional one, and then we're going to fill in a blank here with the IV unit, that is the unit that is on the x-axis, the unit that is the independent variable of blank. This is going to be the IV variable name. Another blank here to fill in the dependent variable name. Increases or decreases, choose one. And then we're going to fill in the slope number and the dV unit. If you practice following this form carefully, you'll make correct slope statements every time. So, for example, let's give ourselves some things to refer to here. We saw this graph yesterday As you sleep more, like if you get more sleep the night before a test, your score will be higher in general. Who knows if that's always true, but we're saying we see that in this data here. So we could say for each additional, I'm just following exactly this format here, 1 hour, that's my unit on the independent variable axis. So this is measured in units of hours. I'm using that unit here. For each additional 1 hour of the variable name on my x-axis, for each additional 1 hour of sleep, the test score, which is my dependent variable name on this graph right here, increases, then I'm going to use the actual slope number, 0.25, and points was my unit. For each additional 1 hour of sleep, the test score increases 0.25 points. Just a note here, like you could include a number of different examples of this if you want them. I'm just going to include one. I am going to include this star. Always include slope number, exclamation point. If your slope statement does not include the slope number, that is whatever number you've calculated as the slope of a relationship, whether that's 0.25 points per hour or 0.25 centimeters per centimeter or 0.75 centimeters per centimeter, whatever your slope actually is, if your slope statement does not include that, then it's not perfect. Notice skill 2G. If we look at the front of the book, we'll see that we've got a bunch of skills recently here. Skill 2G is if the slope of a trend line has physical meaning, I can write a slope statement. So we're going to say this is on page 62. We want to make sure that you know how to do this. This is a skill all on its own. You'll get an entirely like a skill grade based on those slope statements, based on nothing else except for these slope statements and writing them perfectly. So that, by the way, was on page 9. We want to make sure that we use that. I also want to connect to EA2 here. If we look back at page, let's see, where is EA2? It looks like it's going to be on page 53. EA2 is about telling the difference between a variable name and a unit. Notice this is a reason why the difference between the variable name and the unit is so important. The difference between time and minutes, the difference between drop height and meters or centimeters. Because in order to make this slope statement correctly, we need to think this is a unit, this is a variable name, this is a variable name, this is a unit. So let's put this down here. This is on page 53. When you use the slope statement form, check in to page 53 to make sure that you're thinking about EA2 and what's important there.